Awesome. Well, I appreciate the opportunity I'm going to have to talk about some fire effects on soil and water quality. Again, I'm Adam Coates. I'm the prescribed fire chair as of now, and I'm also an assistant professor of forest fire ecology and management at Virginia Tech. And so this is kind of going to be, a good, I think it's a piece that hopefully will interest everyone involved, from landowners all the way to folks that are working for state and federal agencies, just having an opportunity to look at the long-term effects of frequent prescribed fire on soil and water properties, primarily in coastal plain forests. But I think you'll see by the end of this has been something that I've been working on in other locations as well, in other physiographic regions. So what we've got is two long-term research studies that I'm going to try to describe in the coastal plain of South Carolina. In both studies, what we tried to do is characterize fuels, impacts on soil, and then also characterize some water quality parameters, and then also how, when you have surface waters that are treated for human consumption, we're looking at not only the quality of the water, but then also kind of the costs that are involved in treating and how long you have to treat potential contaminants in water. And I think that has implications for science and practice, both on the coastal plain, but then in the Piedmont and also the Appalachians. And hopefully, I'm notorious for running all the way up to time on things. So as we get to the end of this, hopefully I'll leave time for questions, but you can always follow up with me after it. I'll be happy to talk to anybody that would like more information about this research. All right, so we know there are established reasons for using prescribed fire. Those can include hazardous wildland fuel reduction, the promotion of desired vegetation, and then also the control of less desired vegetative species. You can think about wildlife habitat establishment and maintenance, pest and disease reduction. You can think about aesthetics. And of course, these aren't mutually exclusive, right? They can often intersect with one another and overlap. If we're to describe kind of once you begin using prescribed fire, or even if you think about the frequency of wildfires or the lack of wildfires, we start to describe fire regimes. And oftentimes those, the factors that we talk about defining fire regimes are based on climate, the number of ignitions in a given area over a given period of time, and then the vegetation that's characteristic of that location. And then we often describe these factors by fire frequency, the seasonality. It would be, something where we define descriptions of a given fire regime. We use terms like that with intensity and severity, the extent of a burn, and the patchiness. Those are kind of defined as fire regime descriptors. So as we get over the course of space and time, right, you talk about individual flames. We can describe a fire environment as multiple flames actually converge together and burn over a given space in a shorter period of time. We would often describe our fire environment. And then that leads all the way up to a fire regime being described over, decades and then over large spaces of time. And so most of the press, and we're not unfamiliar with this, is that most of the press about wildland fire is going to be focused on wildfires, particularly when you have kind of these extreme mega fire events and events that even go beyond kind of the mega fire description, where you have some of these events that are over 1 million acres in size. That gets a lot of attention. You can just look at California in August of 2020, that kind of the wildfire scenario that was set up. And we had another really strong season this past year. And so that's what a lot of the images and characterizations become. And then we often think about that type of fire regime. That's the kind that I think most of us are introduced to if we're not really actively fire practitioners. And then you contrast that with prescribed fire, right? Where you might have something that, the fire regime you can describe as kind of these frequent or periodic prescribed fires, where you're actually consuming different types of vegetation and different types of fuels than you would have if you were just focused on kind of more of a wildfire regime. So I think some of the language that can get mixed when we describe these fire regimes, comes down to this idea of intensity and severity. What are we talking about, or what are we describing when we use those terms? I think those terms to some degree have been taken by, our popular media. And when they describe things like fire severity, as you can see kind of there in the middle image, right? Fire severity can mean a couple of different things depending on the audience that you're speaking with and how you define it. And so oftentimes I think we merge into, or we separate down into this idea of fire severity based on ecosystem responses as more of the language we would describe to think about maybe duff consumption or organic matter consumption, thinking about mineral soil exposure, leading to the risk of erosion, and overall thinking about vegetation recovery after a burn. We'd often will talk about those things with prescribed fires, right? Is that we have something low intensity and low severity. Oftentimes when we're describing that severity, we're thinking about, the effect on forest floor dynamics, leading to then the fire effects we would often describe both short-term and long-term after a fire event. I think in general from society, you'll see these things described as high fire severity when the societal impacts are magnified. When we think about the loss of life or property, and we think about suppression costs, those are just two examples of the measurables that if you were to read something in a local newspaper, or think about regional or even national news, when they talk about something that's high severity fire, that can often be blended with just these ideas of what society is actually measuring in that, not necessarily the ecological or the biological response that we see, post fire. So, I've done a lot of work. Part of my master's work was looking at when we use prescribed fire alone, and then when we use it in combination with mechanical fuel reduction or thinning, kind of what are the responses, both short-term and long-term, with just single implementations of those practices. How does that affect soil nutrients? How does that affect overall soil physical properties? Thinking about compaction and things like that. So you can imagine, I continued some of that work with my PhD. So you can imagine that when you see a big article like this and come out in peer-reviewed literature, and this one came out in Nature in 2018, the title itself, it says fire frequency drives decadal changes in soil carbon and nitrogen and ecosystem productivity, right? Just by saying fire frequency right there, immediately like the antenna go off in my brain, and I'm sure it does for many of you, is like, well, what kind of fire frequency are we talking about? Are we talking about prescribed fires? Are we talking about wildfires? Are we talking about, when you say just fire frequency, are you talking about high frequency? Are you talking about low frequency, right? There's just a lot that can be mixed into the message of just that title alone, that I think paints a picture that if we're talking about all global fire and you're thinking about the frequency of wildfires, like some of that would make sense in the title. But based on a lot of the work that I had done, looking particularly in the Appalachians, when we were using single implementations of fire, after there had been a long period of time without prescribed fire actually being included in the landscape, and then also wildfires had not occurred in that area, we weren't seeing these drastic changes in soil carbon and nitrogen. And so part of the interest I had in this particular study, probably not the best basis for doing science, but it's also just trying to say, like, I don't think what you're saying is actually true in all situations with all fires that we could measure, in the wildland fire realm. I don't think this actually matches some of what we see in the real world. So kind of to disprove what they were saying, but then also just to highlight, there is a difference between what we can think of as frequent wildfire and what we think of as frequent prescribed fire. We're dealing with different intensities and different severities. So we really want to narrow in on the type of fire that we're describing, and then the specific effects that we would see from the types of fires and the increased frequency you might see differences between prescribed fire and wildfire. Of course, it also talks about a lot of the information about severity. It seemed like in the last handful of years that more information was coming out about wildfire effects on water supplies and water quality. And so we had an opportunity, just with some of the work I was able to be a part of with my PhD and then carry into the initial phase here at Virginia Tech, to think about not only water quality, but then also if you have specific elements in water and you're going to be treating that water for human consumption, how do we deal with particular contaminants that might be, harmful for human health? So again, come back to prescribed fires, right? You're looking here at an image from the Tom Yawkey Wildlife Center in Georgetown, South Carolina, which is kind of in between, if you're familiar with Myrtle Beach and then Charleston, South Carolina. Georgetown is kind of right in the middle, situated there. Thinking about some stands that we had on that island property. On the left, you can see an image of one location that hasn't been burned at all in the last 40 years. And then the one on the right is an example of a location where there's been 20 burns in approximately the last 40 years. Differences that you might note, right? The density of vegetation that's present, differences in the overall vegetation that are present. And so how does that actually shape some of what we could think about with fuels, with soils, and soil response to fire, and then also kind of water quality. So there's two studies that I highlight here. One is on the Santee Experimental Forest, which is actually closer to Charleston, in a town called Allendale, which is only about 12 miles or so from Charleston. And then we have the Tongahke Wildlife Center, as I described, in Georgetown. So at the study on the Santee Experimental Forest, you have two paired watersheds. And so since the 1960s, these two different watersheds were established for research purposes to kind of think about the overall impacts of management, including prescribed fire, but not exclusive to prescribed fire. There were actually some harvests and mastication that have been included throughout the 50 years or so that we were able to look at the management history and the managed location. Then on the unmanaged stand, nothing had been done, including after Hurricane Hugo in 1989, no salvage harvesting was done. So as you could imagine, like the course of succession has run, ecological succession has run its course in the unmanaged watershed. In the managed watershed, you had more representation of pines. There have been more activities that have been included, especially since 2003, of multiple prescribed burns that have been included. So this is characteristic kind of images of the unmanaged watershed and the managed watershed, the unmanaged on the left and the managed watershed on the right. About 41% of the unmanaged watershed was loblolly pine basal area. The remaining was a hardwood basal area. You can see a dramatic contrast on the managed watershed that you had 84% that was loblolly pine and then 16% hardwood. Those hardwoods being a mixture of oak species, sweet gum, and then some red maple that was actually present. The density, you can tell there, was actually substantially greater in the unmanaged watershed. So to look at kind of these responses, I'm taking a big study and I want to boil it down to kind of some nuts and bolts for you. And we looked at overall the vegetative and fuel results, just comparing these two locations, again, the unmanaged stand and then the managed location. Composition was affected. So there was that difference there, not only in density, but then also thinking relative pine to hardwood ratio. Of course, you had more hardwoods actually located in the unmanaged watershed than in the managed, and then more pines in the managed than the unmanaged. Interestingly enough, we did Brown's transects to look at coarse woody debris. And then I did actually take destructive samples and remove litter and duff samples from those locations to kind of come up with a total fuel mass that would be present. Interestingly enough, the total fuel load didn't differ between the managed and the unmanaged location, but you had specific differences based on the size, class, and the types of fuels that you were describing. So some of those differences were 1 hour fuels were actually greater in the unmanaged location. You had 10-hour fuels that were actually higher in the managed stand. So there were some differences there that might be particularly relevant towards any type of fire behavior, whether that be prescribed fire or wildfire that could occur in these locations. But the total fuel load, I think going into that, our hypothesis was the unmanaged stand would have greater total fuels, but we didn't actually see that difference. We did see kind of the lasting effects of Hurricane Hugo, and that there were higher amounts of 1,000 hour rotten fuels in the unmanaged location. And so that's a lot of the debris that was left over after Hurricane Hugo that's still residing in the unmanaged location. And we saw that duff depth changed, of course, that when you had frequent fire and even mastication that was used, you've actually began to alter some of the physical properties of duff, that the depth was actually affected. For soils, right, one of the questions that I had kind of thinking about this was, what would happen if you looked at differences in the chemistry of the litter, the duff material, and then the upper 20 centimeters of mineral soil. And for both of these locations, they were clay ultisols. So, pretty well developed soils that overall have kind of low inherent fertility, but they can be treated and nutrients can be added to make them fertile and productive. But kind of in the situation that they were in, we restricted the study just to these clay soils and trying to think about, well, if you've had these vegetative changes over time between the unmanaged location and the managed location, of course, you would expect, as you think about differences in just the physical characteristics of pine needles and hardwood leaves, for example, like they physically look different. We can define different species based on those appearances. It would make sense that the chemical constituents of those would also be different, right? As you might expect that the phosphorus content in a red maple leaf would probably be different than that in a pine needle. And so trying to kind of build an understanding of, well, maybe some of the successional changes and the vegetative changes that have occurred in these locations, they're related to what's happening with soils, kind of as a result of prescribed fire being used, but also just a result of there's been management that's been done and those vegetative communities have changed. And so we looked at litter chemistry in the top left. You can see here it's labeled as table 3. Of course, there were differences in pH, phosphorus, calcium, magnesium, potassium, and the overall nitrogen percent of the litter materials. Those were greater in general in the unmanaged location than the managed. That tracked all the way down into the duff, with the exception of carbon was actually different in those materials as well in the duff where they weren't in the litter. And so it's kind of suggesting, well, what you saw in the litter of these materials actually transferred into the duff. What we didn't see is that all of those properties went into the upper 10 centimeters of mineral soil and then the subsequent 10 to 20 centimeter soil depth. We only saw that phosphorus and calcium remained significantly different at those depths. But again, they tracked with the differences that we already saw in the litter and the duff for those materials as they would have been deposited on the ground. So again, kind of this idea that management, had an effect on the vegetation that was there. The vegetation then, just by the vegetation itself, maybe independently, not a direct result of the fire itself, but as a result of fire being included in that location, you've changed species, you've changed vegetation, and so you might expect, and we noted that there were differences in the soil properties that were there. When it comes down to water, one thing we were able to do was to, our study was actually conducted about 4 years after the most recent prescribed fire had been conducted. Since that time, they've actually, an interesting thing that's happening at this watershed, and I was going to kind of include this at the end, they're actually taking the loblolly pine that was there on the managed watershed. They're going to be converting that to a longleaf pine stand. And so we'll be able to look at this kind of transition of what happens when you're, taking a stand, restoring it to longleaf, and how the successional changes that will occur in those locations, right? How that might be related to the restoration practices that will be included. But for this particular study, for up to about 16 months after we were sitting at 4 years, and for 16 months at basically when year 4 started, since the last burn had occurred, we collected water samples. And those water samples were collected in a common location, one for the managed watershed and one for the unmanaged watershed. So just basically being able to look at, okay, based on the materials that we have present and looking at the water that we're actually able to collect from these watersheds, what is in the water that we would think of as potential materials that have to be treated for human consumption. One of the things you'll note here is I have a column here for DBPs. Those are disinfection byproducts. And so to describe what happens with those, basically, chlorine is added to surface waters. And then as chlorine is added, of course, that is great to actually make the water better for us. But in that process, depending on what is inherently in that water, chlorine can bind with some of the organic matter and create disinfection byproducts. And the term that I have up there for some of those is carcinogenic. Those would be ones that would be cancer causing. There's some others that just like change in nature and form. They're mutagenic and they become harder to treat. So you have to add additional chemicals beyond chlorine to actually deal with those. There are some that have been linked to breast cancer in females, particularly as they may be pregnant. And so then it actually causes negative birth outcomes as well. So when you see that DBP there, I won't spend a ton of time describing the chemistry on these, but basically we'll look at 2 different types of those that, their formation potential. We were looking at that when we were actually treating some of the water. And so the general gist from this figure here is that overall in the managed watershed, you had in the forest floor materials, they were very similar for the amount of dissolved organic carbon. Well, these are the loads of forest floor materials that were there. So of course we said that overall, when you think of just the litter itself, we didn't have differences in the mass for the forest floor, but we did have differences in the duff, with the managed watershed having less duff material present. That translated into an overall the dissolved organic carbon in that forest floor material right, we saw that it was actually less. So there's less material there that might be treated overall from the managed watershed. When you think about dissolved organic carbon, we looked at it also with total dissolved nitrogen. That's another type of component we would try to treat. Those actually didn't differ between the watersheds, but we did have these significant differences, and it was significantly lower in the managed watershed. The water that was coming off of that, we saw that the disinfection byproducts, the potential to have materials that would be carcinogenic, was reduced in the managed watershed. Thinking about kind of a very similar study at the Tom Yawkey Wildlife Center, the practices that were included there is just prescribed fire. And so very common scenario on that property is that you had approximately over a 40-year period of time, we were able to document the month and overall some very specific fire behavior parameters from about 20 burns that were included over a 40-year period of time. There was a 16-acre stand that was left unburned. And so you can see there that the loblolly pine and longleaf pine are a mix in both of those, the unburned location and the burn stands. But you had basically basal area was more than double in the unburned location. So with this study, we didn't only look at just the difference between burned and unburned, kind of think about this long-term practice. We actually were looking at seasonal implementation of prescribed fire as well. We were able to look at annual dormant season burns, annual growing season burns, and then where we had actually skipped a year in between, did biennial dormant burns, just basically being able to look at some of these chemical elements that would be related to the fuel materials, tracking that into the soil, and then actually looking at that with water quality as well. So all of these burns, they were conducted in February, March 2015 for the annual burns, and then those were followed February through March of 2016. That was when we conducted the biennial burns and then actually did another series of the annual dormant burns. We were able to follow basically the same timeline, a time of year for the dormant burns, just differed by a year, kind of March 9th through the 11th. Annual growing season burns were in May of 2015, and then we did the biennial dormant again in March 9th and 16th in 2016. So as you might imagine, right, you go 40 years without prescribed fire. We have here kind of these comparisons of fuel loading and fuel height. As you might expect, right, the long-term unburned fuels was substantially greater. We actually saw that the actually forest floor mass, dominated kind of all of our treated areas, not a significant amount of really coarse-wooded debris on those locations because you have that frequent fire that's actually been included. A lot of the burns, one thing to note here was that our charred depth, we actually measured kind of our post-fire, in air quotes, our ash that was remaining. One of the things we did was we actually wanted to test the kind of chemistry of the ash to see what was remaining after the burns and thinking about the quality of the organic matter that would be left behind. So we did have a lot of incomplete combustion, as you would imagine, right? These are pretty fast-moving surface fires, low intensity, low severity. And so what we did see when we looked at the chemistry of those is that the long-term, and this is a type of analysis called a principal components analysis. It's just when you have a lot of variables that you're trying to measure and you're trying to see how they might be correlated together. Not necessarily finding statistically hard differences between them, but just what might be related together. What we did see is that when we looked at the long-term unburned materials, they tended to be dominated by materials that were harder to break down, and then actually they were dominated by a higher proportion of litter mass, as you would most likely expect. We did look at materials that would have been affected by long-term burning, but they weren't recently burned. They'd gone about a year in between burning. So what is the chemistry of those and what did that look like? As you might imagine, there was more, we saw that the higher degree of coarse woody debris was actually there before we did any burning in locations that had been frequently burned previously. It also tended to be that those materials had a higher percentage of lignin and phenolic compounds that are really good. They're great for burning because they hold fire for a long period of time. And those were characteristic of kind of the areas that had a higher pine needle content, which are in the frequent prescribed burned areas. After we burned, the ash materials were most associated with what we describe here as polycyclic aromatic hydrocarbons. And the idea with that is those are often things that are produced because of combustion, but they often are the things that are related to poor water quality as well. And so this isn't suggesting that this was found in the water. It's just the idea that it was most found in our ash materials when compared to these other types of materials we looked at. And so the differences here, we really weren't finding, if you were to compare our ash materials after you had conducted a fire to what those materials looked like before any burning was done, right? We weren't finding these great percentage changes that any particular contaminants were being created in drastic percentages by frequent prescribed fire. Again, like looking at the materials before you burn them and then looking at samples of the ash from those same materials, you weren't seeing this great increase in polycyclic aromatic hydrocarbons and other things we might really be concerned with when we get to the water quality or the water treatment process. These were the types of soils that we were looking at. So this is in general, this is a spodosol, not necessarily an entisol or extremely sandy soil where there was some clay accumulation in some of these, but overall, an overall sandier soil, but not just like beach sand. One of the unique things about this property that I didn't mention earlier is a lot of the management that's done is for wildlife habitat and red-cockaded woodpeckers. You're actually looking at that image on the right. That is a bald eagle's nest up in one of the stems. And so again, looking at the soils here, kind of the idea of, we did a more complete kind of soil fertility profile here, looking at more nutrients and that sort of thing. But again, really what we were seeing from the top 10 centimeters of mineral soil, and then the subsequent 10 to 20 centimeters of mineral soil, we weren't seeing these drastic differences in some of our principal nutrients like calcium and like magnesium, phosphorus. So we weren't seeing these drastic differences included regardless of what type of burning practice you used, whether that be no fire at all or some of the sequences of when you had stands that were frequently burned. We were able to look at, well, if this one was burned 4 times in the last 10 years, 6 burns, 8 burns, we were able to kind of compare some of these differences in between. We noticed some differences. To be honest with you, some of these differences we saw in iron and sulfur, like they're less descriptive of potentially biologic changes in soils. Still trying to figure out what those might be, but in the literature, there just doesn't seem to be a lot of effects from those. Our water study, and I know I'm running up on time here, for this one, we didn't have actually active draining watersheds to measure. We took materials that were both burned and unburned from the long-term unburned stand, and then before you used any fire where there had been frequent burning applied. And then looking at our ash materials, we basically looked at the same components we did in the Santee experimental forest. Rainwater ran over those materials for a year. And then we looked at dissolved organic carbon. We looked at the formation of potential disinfection byproducts. And as you can see from almost all of these, the potential contaminants were basically double. Kind of looking at this leachate water quality, they were essentially double on most of between the burned locations and then the unmanaged stand. The treatability that you see here, basically that was similar regardless of which location we were looking at, burned or unburned. So you can treat those materials. One of the questions becomes, well, if there's just inherently more of those materials, the cost is going to be greater. So you can treat them, and that's great, but you actually then have the cost of doing that. If you have double the amount of material, you can probably expect that the cost is going to be greater as well. Actually, what we were trying to describe too in the research paper we did with this is, with the prescribed burning, you can almost estimate the pulses of when those materials were going to enter the water supply. And so not only could you effectively treat those materials for less money, you could actually dedicate the time period that you needed to treat them, which would be less kind of determined with the unmanaged stand, because it seemed like there were consistent pulses regardless of any type of season of the year. It seemed like there were continuous pulses. With the prescribed fire material, you actually got the pulses directly after the first 1 or 2 rainfalls after the prescribed fire had been conducted. So long term, right, this could have some broad implications, is that, when you see in the Santee study, we saw that the vegetative changes that occurred, that actually led to some chemical changes. And whether that's good or bad, I think that's up to the overall management practice that's included at that location, right? For some wildlife purposes, or maybe even for some of the desired vegetative species that were in the unmanaged stand at the Santee Experimental Forest, for example, that might be desired in some cases. But I think the chemical changes occurred as succession had, rapidly advanced in the Santee Experimental Forest and the unmanaged location when fire had not been included. Of course, when fire was included, you had vegetative changes, and that transferred into the soils and then also the water quality. At Yawkey, I think is a pretty standard case there, where once prescribed fire was included, we didn't see these drastic changes in the species composition that was there necessarily, still predominantly pine areas, but you did see kind of these substantial changes in the fuel loading that was there from the forest floor standpoint, and that directly transferred into just the total load that would have to be treated if water exiting those locations was used for human consumption. And so maybe we add water quality to these lists of established reasons for prescribed fire use, right? There's other studies that have been done where they looked at water quantity exiting watersheds that had been burned, and you actually see that there's greater water amount available when you've used frequent prescribed fire, because there's less vegetation there actually taking that moisture and evolving it in its life cycle. And so if you actually are then able to say, well, water quality has been improved as well, that's kind of a big deal in the realm of management and the implications of what our management practices might include. So, and I was going to highlight this, but as I promised, I will run out of time. But we're looking at more kind of the dynamics of different ecosystem responses in other locations than just the coastal plain at Virginia Tech. As I mentioned yesterday, we have a wildland fire miner now. I've actually have 5 female graduate students that are working under my advisement right now as well. And the ones that have graduated have found placement in the working world. So that's been great as well. But with that, I probably don't have time for questions, but I'll be glad to follow up with you at any point in time about this research and other stuff we have going on at Virginia Tech. So appreciate the opportunity to talk. I know I talk fast and that was a lot of information, but hopefully that's useful for you.